Okay, good morning. So, in the series of these online classes, now we came to another part of the chapter, Congruency of triangles. In previous video, that we have all seen that few properties and their uses with the different examples in the triangles. So let's begin with some more examples of the next exercise 7.2. So let's begin with a question of that exercise. There is a question given in that exercise that the isosceles triangle ABC, which is having two sides AB and AC equal, having two altitudes from B and from C on two sides AB and AC, like this. Okay, these altitudes are D and E, given in name. Okay, so what is given to us in triangle ABC? AB and AC are equal, that is given to us, and with them BD is perpendicular on AC and CE is perpendicular on AB. So these things have been given in the question. What we need to prove is, we need to prove that these two altitudes are equal. That means BD is equal to CE, that we need to prove. So let's come to the proof. How to prove that? Okay. Let's see. The first step, as I have said to you, is the triangles which have to be compared with each other. So let's see which triangles we should take. Either we can take this ABD and AC triangle, or we can take this DBC and ECB triangle. Okay, these both triangles we can take. No problem with that. But as you can see that ABAC have been given to us, and we would always like to use whatever have been given to us in the given section. So that's why we are choosing the triangle in which AB and AC comes. So we are choosing ABD and AC triangle. So in triangle ABD and triangle ACE, first of all. And as we have chosen this, because of this, we are taking first AB and AC as a comparison which is given already in the question. Okay, let's move on to another thing. There are two perpendiculars have been given. The perpendiculars is making the angle 90 degree on the opposite side. So that's why we are taking it ABD. This D angle is 90. So I am writing here as ADB is 90 degree. And similarly, the angle AEC is also 90 degrees. So I am writing it here AEC, both are 90 degrees. So these two triangles are having 91 angle of 90 degree. Now the third thing. Is what? The third thing is the angle A, which is common in both. As you can see, in the triangle ABD there is angle A lie, and in triangle AC also this whole angle lie. So we can say this angle A is a common angle in both the triangles. Remember kids, we need to always verify, or we need to check whether any common thing is in the given triangles or the parts of the triangle. So likewise, as you can see, there are two angles and one side is in common. So the sequence of this will be angle side angle or angle side. Okay. So as you can see, these two angles and a side, these two angles and a side. So we can take by AAS. Okay. Congruency criteria. Both triangles are congruent. So triangle ABD is congruent to triangle ACE. As I have told you, this AAS exists, but SSA doesn't exist. There is a specific reason. You don't need to forget that also. So with this property, these triangles are congruent, and since they are congruent, we can tell that this PD, the third side, is equal to the third side of the other triangle. So that BD is equal to C by our favorite property CPCD. Okay, congruency parts of corresponding parts of congruent triangle. Okay. So likewise we will prove it. So this is hence proved. Whatever I have to be shown. Okay. So this is how we need to do that kind of questions. Let's take another question based on the same concept from the same exercise. Okay, which having some complexity in it. There are so many complex questions is about to come. If we talk about this congruency triangles, the one portion which is explicit, that is inequalities in triangles. Inequalities is one of the major part of the chapter, but since it is omitted because of reduced in the syllabus, this is the extra part, so that it has been removed by the board. Now see one more question. I am going to take one different question for you. ABC is a right angle triangle in which angle A is 90. Okay. So I am making a triangle ABC here. Okay. This is how I am making ABC. So ABC is a right angle triangle. I am making a right angle at B. Now what it says? AB and AC are equal. AB and AC. So that this A will come like this. So AB, AC will be equal. See, remember always that in right angle triangle, hypotenuse is the greatest side. So it won't be equal to either any of the side. Okay. So I am taking A as a center, so that AB and AC can be equal. Now we need to find the angle B and C. This is the question. We need to find the angle B and C. Okay. Now remember this. In a triangle, we can apply angles and property. Now, as you can see, this is called an isosceles right angle triangle. Why is it isosceles? Because the two of its sides are equal, which are perpendicular and base. As you can see that perpendicular and bases are equal. So we can apply that property. So first what we are doing here is we are using that property of isosceles triangle. So since you can write in triangle ABC, I am writing it directly. Since AB and AC are equal, so angle ABC is equal to angle ACB. And what you need to write here? You need to write here angle opposite to equal sides. Opposite to equal sides are equal. That you need to write. Okay, this is the property. Angle opposite to equal side. In a triangle specifically, if two sides are equal, their corresponding or opposite angles are equal. So this doesn't happen in two different triangles. It happens only in one triangle where two sides are equal, like an isosceles triangle. So angle opposite to equal sides are equal. Okay, and now we can apply by angle sum property. Angle sum property. If you don't memorize this property, you can write by isosceles property also. In isosceles triangle also two sides and two angles are equal. This is the property of isosceles triangle. So now by angle sum property, this two angle we are assuming as S, so that angle ABC plus angle A plus angle ACB, this three angle sum is 180. Now these two angles are same, so I am writing it as two angle ABC plus 90, the angle A value equal to 180. Just transpose it. So 2 angle ABC is equals to 180. So that one angle is becomes 90. So that angle ABC and ACB. Okay. Sorry, this will become 90. So that it will get cancelled. So that 45. So both angle becomes 45 now. So this is how you get the. See, in mathematics, whenever this some things have been given you already, how to prove another thing, that you need to write some write-up for that. Okay, we can't give the answer directly. Okay, that you can't do like that these two angles you assume equal and you just put the value as x and you just do it. Like so, this won't be happen. You need to give some of the other statements. In like that, in that question, you need to write this statement because it is necessary, it is demand of the question to write what formula or what logic you are applying here. Okay, let's see another question based on this phenomena in the exercise. Okay. In an isosceles triangle, AB and AC are equal. Okay, let's see. So this is example 3. In a triangle, isosceles, AB and AC are equal. See, very carefully just see that question. In this triangle, AB and AC are equal. What we are doing here is we are extending this BA, okay, on that side, so that I am just extending it, so that's why I am making as a dash, okay, up to D, such that this AD and AB are also equal. Okay, so what is given first? First I am writing there that given is in triangle ABC, ABAC are equal and AB extended to C, extended to D, such that AB and AD are also equal. Like that, it is given like that. What we need to prove? We need to prove that BCD is right angle. Okay, that means we need to show that if we join this with C, this will be right angle. Okay, now if you understand by reading this question, there needs to be isosceles triangle property needs to be applied. So let's see that. Okay, so in proof, what we are doing here. Okay, so to make it easy, what we are doing here, we are numbering the parts of the angles. Like this is angle 1, this I am giving angle 2, this angle I am giving 3, and this angle I am giving the name 4. So I am naming the angles so that what types of angle, because see, I am naming the angles of the opposite side which are equal to each other. Like ABAC are equal, so that I am naming opposite angles of that, and AD are also equal, so that I am opposing this equal sides opposite angles I am marking. Let's see now. In triangle ABC, we are applying that same property what we are applying here. In triangle ABC, AB and AC are equal given. Yes, it is given they are equal. So that I can say that angle 1 and angle 2 are also equal. Okay, the reason again the angle opposite to equal side. Opposite to equal side. Whatever we are using here first, same property we are using in that. Okay, I am just leaving this statement as giving it equation 1. Now let's move on to other triangle. In triangle ACD now. In triangle ACD, AC is equal to AD and AB is equal to AD. So that means AC and AD also equal. Okay, this equal to this and this equal to this. That means these are also equal. दोस्त का दोस्त होता है. It's very simple. So that says they are equal, they also are going to be equal. So that's why AC, AD in that triangle are equal. That's why angle 3 and 4 are also equal, because by the same property angle opposite to equal side. Opposite to equal side. Okay. Now this is I am giving equation number 2. Okay. Now, the final statement. The final statement comes from the triangle which have been as a whole. It is showing that DBC is also a triangle. So, in triangle DBC, okay, we are not counting A here now. DBC is also a triangle because in DBC this angle C comes, which need to be proved 90 degree, BCD angle. In that BCD there is no A. That's why we are just excluding it. So in triangle DBC, by angle sum property. Okay, so I am going to apply this property, angle sum property. Let's see that property what says. This angle 1, this 2 and 3, and that another angle 4. These all angles will added up so that sums up equals to 180. Now, Now, as you can see, this 1 and 2 are equal. Okay, I'm just removing that bracket, sorry for that. I just want to show that this 2 and 3 is a part of the same angle. That's why I put it a bracket. Now 1 and 2 are equal by equation 1. So I can write this 1 and 2 as 2 and 2 means 2 angle 2. And this 3 or 4 also equals, so I can write it as 2 angle 3. Why only I write 2 and 3 angle, not 1 and 4? Because 2 and 3 only making C. So that I have taken this 2 common, this angle 2 plus angle 3 is equals to 180. This 180 will get cancelled by this 2. This angle 2 plus 3 is angle C. So that it's proved that BCD is equals to 90 degree. This is hence proved. ओके आपने हिंदी में वो मुहावरा सुना होगा कि है ना, जैसा माथा होता है वैसे ही टीका लगाया जाता है ना, माथा देखकर टीका लगाना. सो दैट मीन्स कि अगर आपको माथा बड़ा है तो बड़ा टीका लगेगा, छोटा माथा तो छोटा लगेगा, है ना, पुरानी कहावत है. तो यहाँ में वही कर रहे हैं, वॉट एवर एंगल वी नीड टू प्रूव 90 डिग्री, दैट एंगल ओनली वी आर फोकसिंग ऑन टेकिंग इन दिस सीक्वेंस. Okay, so this is very simple question. This is a significant question, and this question specifically from this exercise is very important because it's come alternately in each and every year or alternately. So that's why this question is very important because it represents the property of making such kind of triangles. Okay, isosceles triangle. So that's here again. I'm giving you briefing that we begin with the isosceles triangle in which AB and AC are equal. There is another extended part which is having AB equal to AD. Then we join it together and we need to show that BCD is a 90 degree angle. So what we did here, we need to first isosceles triangle ABC in that AB and AC are equal, so that opposite angles are also equal by the property opposite angles. Opposite angle opposite to equal side are also equal. And in the other triangle also the two sides are equal, so that this is also an isosceles triangle. We need to identify it and the opposite angles also equal. This 1 and 2 we need to use so that we put this whole triangle BCD and prove that by angles of property the sum of these angles are equals to 180. So as you can see, this 1 and 2 part equals, so I write 2 angle 2 not 2 angle 1. Why? Because 1 is not the part of that C which need to be proven. So that's I wrote it as 2 angle 2. This 3 and 4 also equal. I wrote it 2 angle 3 because this 3 part of this C. So this I have taken this 2 common. So that 2 plus 3 becomes the angle C, which need to be shown 90 degrees. That's how we need to do that question. Okay, but let's see one more question so that we can wind up with the chapter. Here I am just rubbing it. There are a lot more questions. Since the inequality part has been removed because it is very confusing for the students which are the first time members of this chapter. So it is very good thing that they have revoked that part. Now we are taking a different example. Example number 4 we are taking. Example number 4 we are trying to take different questions so that you can understand it better. Now we are moving to the part which is having RHS property, so I think that we might do some RHS type of question also. See, DE and CF are two altitudes. See, remember that question that we did in example number 2? So that kind of question we are doing. That in triangle ABC, DE and CF are two altitudes. So ABC, BE and CF are two altitudes. I am giving BE and CF. Okay, these are two altitudes. Okay. Now what it is saying in the question? It is saying that BCF are two altitudes on the triangle ABC. Using RHS rule, prove that the triangle ABC is isosceles. We need to prove that triangle is isosceles. So what is given to us? Given to us, it's very easy that E is perpendicular on AC and CF is perpendicular on AB. What we need to prove is, we need to prove that AB and AC are equal sides, so that we can say that triangle ABC is an isosceles triangle. That we need to prove. So let's see, students. In proof, what we are doing here. See. Again, the first thing, what we need to do first we need to do what? We need to take two triangles. Now, but remember this time, now this time we need to use RHS congruency rule. Okay. So for RHS congruency rule, we can't use the above triangle that we took before as ABE and ACF. This time we need to take different triangle to show that. Okay. So what we are going to take, see. The altitudes have been given equal? No, equal altitudes have been given to us. Now in that B and C have also given equal to us. So this is also good thing. So what we are doing here, this time we are taking the lower triangles. Okay. So now in triangle, this base triangle EBC and triangle FCB, these two triangles we are taking, EBC and FCB. Let's take this triangle. In ABC and FCB, this BE and CF have been given equal to us. Second, their altitude, so that BEC angle and CFB angle both are equals to 90 degrees. Okay, these two things. And the third thing is common, that is BC. So that BC side is common in both triangles. Now, as you can see, this BC is actually the hypotenuse, because since these both angles are 90 degrees and opposite side of 90 degrees also hypotenuse, always hypotenuse. So that by RHS congruency rule, what we can say is these two triangles EBC is congruent with this another triangle FCB, and since they are congruent, we can say that what we can say is, we can say this FB and BC side are equal. Okay. And angle B is equal to angle C also we can say. Okay. In EBC is C angle and in FCB is B angle are equal. Angle B and angle C are equal by simplicity. Our favorite corresponding parts of congruent triangle. Now see, now our question is, we need to prove that AB and AC are equal. So what we are having is a different thing from what we have to prove. So what we are doing here, now see the result. Angle B and C are equal. That means what? Opposite angles are equal. And we know, what we know, that angle opposite to equal sides are equal. So in triangle ABC, in whole triangle, if angle B and angle C are equal, this is only possible when side AB and AC are equal. Okay, this is only happens when B and C can be equal when AB and AC are equal. This only happens in isosceles property because it is isosceles property. So by that converse property, we can say that AB and AC are equal, and since AB and AC are equal, therefore the triangle ABC is isosceles. So sometime we need to prove the statements like this also, converse theorem. So we just apply that converse theorem. Okay, so please try to do this kind of questions repeatedly so that you can understand it better. Okay, so keep studying, be safe, and have a nice day. We'll meet next video. Thank you.